Hey everyone, welcome back to Gurukul. Now we are going to start video series for MV HINDSHIP, and MV HINDSHIP is a part of Function 3 written exam. Now before we start, let's see the structure of Function 3 written examination. So Function 3 has total 200 marks and you need more than 120 to pass this exam. There are two parts, Part A and Part B. In Part A, you will get one question for the diagram, that is from the ship's construction, and you have two numerical problems. In Part B, that is the theory part, you have 6 questions. From that you have to attempt any 5. From these two numerical problems, we have one from MV HINDSHIP and one from ship stability at the operational level, that is by Captain Subramaniam. So there are 8 questions which you have to attempt. There will be 9 questions actually. You have to attempt any 8 of them and each carry 25 marks. That makes it of 200 marks. Now I forgot to tell you very important part, that in Part A you have one question from the ship's construction, that is for the diagram, and 2 numerical problems. From these 3 questions you don't have any options. These 3 questions are compulsory to be attempted. You have options only in Part B, that is you have 6 questions and you have to attempt any 5 from these. So that's why in Part A, as you don't have any options, so it's very important to prepare for the diagrams and for the numerical problems. And Part A itself consists of 75 marks. So if you get any problem in Part A, then it's very hard to clear the exam, because if Part A is not prepared, then you will lose 75 marks, and after losing 75 marks you have only remaining 125, that is from Part B, and it's not possible to get all the 25 marks from Part B, so there are chances that you will get failed. So without taking much time, let's start MV HINDSHIP now. So now in this video we will start with the familiarization of the trim and stability booklet, because when we are solving any questions we have to find the values from that booklet, and if we don't know from where to take these values, then it's obvious that the answer will be wrong. So it's very important to familiarize with the booklet. In MV HINDSHIP they have given these few questions to familiarize with the booklet, whereas if you are solving ship stability, that's by Captain Subramaniam, in that you will get the dimensions of the ship or any value that will be mentioned in the questions. But whereas in MV HINDSHIP everything will not be mentioned, so you have to find the values from the trim and stability booklet. So first question is, find the LBP, that is length between perpendicular and molded breadth of MV HINDSHIP. So for that now we have to open trim and stability booklet of MV HINDSHIP. Okay, so this is the stability table for MV HINDSHIP, and on the next page they have mentioned these densities that we have to use for solving any questions. If they have mentioned in the question, then we have to consider that one. If they have not mentioned, then we have to use these values, and they have explained terms with the formulas, how to use GM or kg, what is kg, what is GM, so that is given here. Now on next page they have given index, and after that this is the general particulars of the ship. Now we have to find LBP, that is length between perpendiculars. So here they have given length between perpendiculars. So length between perpendiculars in meters, it is given 143.160 meters, and this is the value if you are using feet, but in questions we use meters. So this is the LBP, that is length between perpendicular, and the molded breadth that is given here. So the breadth molded, that is 20 meters. In general particulars you will get dimensions of the ship, GRT, NRT, and all other values. As we have sailed on the ship, we have seen general particulars in bridge or in ship's office. Now let's move to the next question, that is question number 2. Locate the criteria of minimum stability requirements as per the code of intact stability. So after general particulars, so general particulars are on page number 3. After that go to the next page, and here on page number 5 they have given the stability criteria, that is given here. So that is A, area under curve up to 30 degree to not less than 0.055 meter radians, B, C and D. So this is the intact stability criteria for this ship. Here also they have given the graph for the stability curve. Now let's move to the question number 3. Find the displacement TPC, MCTC, LCB, LCF, VCB, KM, KML at a draft of 4.2 meters. So on the next page, here they have given the conversion table if you want to convert any units, and after that they have given hydrostatic particulars. So this draft is the hydrostatic draft, and we have to find the displacement for 4.20 meter of draft. So for that we have to find 4.20, that is here they have given 4.20 meter. So this is the column for draft. After that they have given displacement, then TPC, MCTC, LCB, which is measured from the arc perpendicular, then LCF, that is longitudinal center of flotation. This is for center of buoyancy, LCB. Then this is vertical center of buoyancy, and this is transverse metacenter, and at the end they have given this longitudinal metacenter. So we have to find all for 4.20 meter of draft. So this is the row for 4.20 meter of draft. So the displacement will be 8038 metric tons, TPC will be 21.72, MCTC will be 160.7. So these are the values we have to use for 4.20 meter of draft. Now question 4, find the capacity of number 2 twin deck. Now go to the next page. In next page again, this is the continuation of hydrostatic particulars. After that, in page number 10 they have given capacities and center of gravity for dry cargo spaces. In 11 they have given for storerooms. Then on page 12, capacities and center of gravity of storerooms, crew and effects, and for deck cargoes. Then after, capacities and center of gravity of refrigerated cargo domestic chambers. And on 14th, capacities, center of gravity and free surface movements of oil and other tanks. Now we have to find for number 2 twin deck. So on page number 10 they have given capacities and center of gravity of dry cargo spaces. Here you can see they have given for 5 holds, and after that they have given for twin decks. So now this is number 2 twin deck. Here you can see the capacities. So for number 2 twin deck, the capacity is 1854.9. Now why we use the grain capacity? Because grain capacity is the actual capacity of that space, while bale capacity is always less than the total capacity of that space. So the capacity of number 2 twin deck is 1854.9 cubic meters. Now question number 5, find the LCG and kg. LCG, that is the longitudinal center of gravity, and kg of number 3 hold. Now again open the trim and stability booklet. So on the same page they have given the center of gravity here, and for cargo hold number 3, which is given here. Now from the center of gravity we have to find vertical, that is above keel. So vertical center of gravity, that is kg, is given here, that is 5 meters. And after that they have given vertical movements. In the next column they have given longitudinal center of gravity. Here this is 80.63. So LCG is 80.63 meters, and kg, that is vertical center of gravity above the keel, is 5 meters. In question 6, find the capacity, kg, LCG of number 4 db tank center. Now on this page, as you can see, they have not given any data for double bottom tanks. So let's go to next page. Now here they have given for stores. This is for the storeroom and crew effects and deck cargo. This is the capacity and center of gravity for refrigerated cargoes. And here you can see on page number 14 they have given capacities, center of gravity, and free surface movements of oil and other tanks. Okay, now we have to find capacity, kg, that is vertical center of gravity, and longitudinal center of gravity for number 4 db tank center. So as you can see here, they have given the capacities, center of gravity, and free surface movements of oil and other tanks. Now this is number 1 db tank, 2, 3, and here they have given number 4. Now in number 4, this is port, starboard, and this one is for center. We have to find for center tank. So this is the row. We want capacities. Capacities are given in this column. So this is the full capacity of the tank. So the capacity will be 257.4 cubic meters. On the other side they have given capacity for 98%. Now we want center of gravity. So center of gravity is given here. This is the vertical center of gravity, and here is the longitudinal center of gravity, that is LCG. So in this column, so the vertical center of gravity, that is 0.63 meters, and LCG is given here 57.58 meters. LCG, that is longitudinal center of gravity. So question number 6 is finished. Now let's move to the next question. Find the weight of ballast tank in the aft peak tank when it's full. So here they have not given for aft peak tanks. Now go to the next page. So on this page they have given for aft peak tank, which is here, aft peak tank, and the capacity is given here. This column is for 100%, and this column is if the tank is filled up to 98%. Now here, as you can see, this is the capacity, which is the volume of the tank. It's given in the cubic meters. So the volume is 117.8 cubic meters. So this is only the volume. We want weight. Multiply 117.8 with the density of the seawater, so that will be the ballast of the tank. So 117.8, that is the volume of the tank, but we want the weight of the ballast. So if it's filled 100%, now we multiply 1.025, that is the density of the seawater, with this volume, that is 117.8 cubic meters. Then after we will get the weight. So if you multiply, then the answer will be 120.745 tons. You can do it in calculator and you can match with this answer. In question 8, find the moment of inertia for number 12 dB tank starboard side. Now we have to find the moment of inertia for 12 dB tank starboard side. So for that, move to the next page, as they have not given the moment of inertia here. On this page, that is the page number 19, they have given free surface corrections. The column is given here. These are the compartments, and they have also given the frames for that compartment. Now we want the moment of inertia for 12 dB tank starboard side. Moment of inertia is 17, and for that answer is 17. Next question, find the Kn value at a displacement of 13,500 tons when held 40 degrees. For Kn value, go to the next page. Now here they have given the Kn values, but we want for 40 degrees. So go to the next page. Here this is the column for 40 degree, and we want for displacement, that is 13,500 tons. So the displacement is given here in this column, and 13,500 tons is given here. And for that, the value of Kn is 5.845 meters. Now here they have mentioned for column A, that is the Kn value without the superstructure, and B is with the superstructure. We want the value of Kn of the ship, because the ship has the superstructure, so that's why in that case we have to take the value of B. Now this difference you will find only after 30 degrees, and even in 30 degrees you will find the same values, but even if it's same, still you will have to use the column B. In next question, in question number 10, we have to find the draft, freeboard, displacement and dead weight at winter load line. Now for that, go to the next page. Now here on this page they have given all the details regarding the load lines. Now we want for winter load line, which is mentioned here. This is the row for the winter load line, and this is the column for drafts. So the draft will be 9.041 meters for winter load line. We want freeboard, so freeboard in meters will be 2.818 meters. For displacement is given here. This is the column for displacement, that is 19,151 tons. And this is the dead weight mentioned here. So the dead weight is 13,651 tons. In next question, we have to find the freshwater allowance of the ship. So freshwater allowance, that is the difference in draft if the ship is floating in freshwater and if the ship is floating in seawater. The difference between those drafts, that we called as freshwater allowance. So the difference in the draft we can see from the plimsoll line. Here is the difference between these two drafts. So they have mentioned the difference, that is 202 millimeters. Or if you want to calculate the freshwater allowance, then take the summer draft here, that is 9.233 meters, and take the draft from the freshwater load line, that is 9.435. So if you will calculate the difference between these two drafts, then the difference will be 202 millimeters. That is the freshwater allowance for that ship. Now this is the last question, that is question number 12. In condition number 5, find the following. So first we have to find weight of cargo in number 5 twin deck. Now go to the condition number 5 in trim and stability booklet. Okay, so this is the condition number 1, 2, 3, and this is the condition number 5. So in condition number 5, first we have to find the weight of cargo in number 5 twin deck. So the weight of cargo in number 5 twin deck, here they have mentioned for twin deck. We want for number 5 twin decks, which is here. So the weight of cargo, that is 715.8 tons. Next we have to find longitudinal movement of number 5 dB tank starboard side. So here is number 5 dB tank starboard side, and the longitudinal movements is given here in this column. We want for number 5 dB tank, so this is the row for number 5 dB tank, and this is the column for longitudinal movements. So the answer is 1510 meter tons. That is the longitudinal movements. Next is total free surface movement of the ship. So free surface movement is given in this column. We want free surface movement for the ship, so that is given in the last. So the free surface movement of the ship is 1552 meter tons. Now we have to find displacement of the ship. So the displacement is mentioned here. This is 18,529.3 3 tons. Above this displacement they have given dead weight and light ship, which is mentioned here, but we want only displacement, so the displacement is 18,529.3 tons. Now we have to find vertical movement of the ship. So for vertical movement, the column is here and the vertical movement for the ship is given at the end. This is 1,39,700 meter tons. That is the vertical movement of the ship in condition number 5. Now we have to find kg of oil in storage and settling tanks. Now for kg of oil in storage and settling tanks, we have to search in these rows. So they have given here, this is for storage and settling tanks, and the column for kg is given here. So kg for storage and settling tanks, this is here 6.46 meters. And we have to find the weight of the mail cargo. So mail cargo is mentioned here. So this is mail cargo and the weight for mail cargo is 5.1 tons. Now we need to find the LCB of the ship in condition number 5. So the LCB is given here and the LCB is 72.356 meters. At the end of table you will find LCB, displacement, MCTC and other values. So the LCB is 72.356 meters. Next we have to find hydrostatic draft. Hydrostatic draft is given here, that is mean draft 8.785 meters. Below this they have given draft at aft perpendicular and draft at the forward perpendicular. Next we have to find trim. So the trim is given here, this is trim by stern and the trim is 0.201 meters. Next we have to find kg and FSC, that is free surface correction. So kg is mentioned here in this column and in the same column go to the end, and here at the end this is the kg of the ship, that is 7.539 meters. That is the total kg. If we want kg for the light ship, then the kg will be different. For dead weight the kg is different, but we want for the ship. So in condition number 5 the kg of the ship is 7.539 meters. After that we need to know free surface correction. So free surface correction is given on the next page. In the booklet it's given on the right side. So this is the free surface correction given here. So the free surface correction is minus 0.084 meters. And above that they have given also km, kg, gm solid and corrected gm, that is gm fluid. So for calculation we have to use this one. This is corrected gm, that is gm fluid. So next is writing lever at 10 degree heel. So writing lever, that is GZ, is given here. So for 10 degree the value of GZ is 0.191 meters. Now we have to find area under GZ curve up to 40 degree. Area is given here. So area under GZ curve up to 30 degree, between 30 and 40 degree, and this is the total area to 40 degrees, that is 0.237 meter radians. Then we have to find maximum GZ and the angle of heel at which it occurs. So to find maximum GZ they have given this graph. On the y-axis they have given GZ and on the x-axis they have mentioned angle of heel in degrees. So the maximum GZ is given here. This is the maximum GZ here, and the maximum value for GZ is given here, that is 0.650 meters. And they have also given the angle of heel, that is 41.5 degrees. So at 41.5 degrees the GZ will be maximum and the value of GZ will be 0.650 meters. Now the last question is LCF of the ship. So the LCF was given on the previous page. So here below LCB they have given LCF, which is 49.07%. So they have given the percentage. We have to find in meters. To find in meters, we know the length between perpendiculars, that is 143.16 meters. We have to find 49.07% of 143.16 meters, and that will be the LCF of the ship. So to find LCF we have to find 49.07% of 143.16 meters, that is the length between perpendiculars. So after calculation we got 70.249 meters, and that is the answer. I hope you find this video helpful. If it's helpful, then do like the video, do subscribe the channel and share it to your friends for preparing for exams, and do comment in the comment section if you have any doubt. We will cover in the next video. Thank you and have a great day. See you soon in the next video.